Your web browser cannot understand website names like google.com or wikipedia.org. Computers only communicate using complex numeric addresses called IP protocols. Yet thousands of translations happen in milliseconds every single time you click. How does the internet instantly map human words to numeric hardware addresses? The system performing this miracle is known as the domain name system. Without DNS, you would have to memorize dozens of random numbers daily. DNS is the foundational directory, holding the entire modern web together. DNS relies on a distributed tree structure rather than one single machine. At the very top sit 13 strategic root server clusters worldwide. Below the root are top-level domain servers managing extensions like .com. Authoritative servers store the official final mapping for specific domain name. You type a web address into your device to start the query. First, your browser checks its internal cache for stored recent lookups. If missing, the request queries your operating system's local DNS cache. Next, your computer contacts your internet service provider's recursive resolver server. The resolver acts as a detective, hunting for the correct IP address. The resolver first asks a root server where to find .com. Root doesn't know the exact IP, but points to TLD servers. The resolver immediately queries the .com TLD server for the address. TLD responds with the location of the domain's authoritative name server. Finally, the resolver asks the authoritative server for the exact IP address. The authoritative server returns the precise numerical IP address to resolver. The resolver saves this result locally, so future queries resolve instantly. The resolver delivers the numeric IP directly back to your browser. Now your browser connects straight to the destination web server machine. DNS doesn't just route websites, it manages entire digital services. A records map names to IPv4, while A records route newer IP6 addresses. Mail exchange records direct incoming emails straight to proper mail servers. CNAME records alias one domain name seamlessly to another underlying address. Aggressive caching dramatically speeds up internet browsing across all device networks. Anycast technology routes your request to the geographically closest DNS server. Massive websites use DNS load balancing to distribute traffic across data centers. Originally, DNS queries were unencrypted plaintext, visible to network eavesdroppers. Attackers can poison DNS caches to redirect users to malicious websites. Overwhelming DNS infrastructure with junk traffic can take entire platforms offline. Updating a DNS record requires time to propagate across global caches. DNSSEC adds cryptographic signatures to verify that records are completely authentic. DNS over HTTPS encrypts queries inside standard HTTPS web browser traffic. DNS over TLS wraps requests in dedicated encrypted tunnels at port 853. Modern privacy resolvers block trackers and prevent ISPs from logging queries. Blockchain and decentralized technologies are exploring tamper-proof domain resolution systems. DNS is far more than a simple phone book for web addresses. It is a dynamic, planetary database executing trillions of lookups daily. Every website load relies on thousands of servers working in synchronization. Next time a page loads instantly, appreciate the invisible network behind. Elegant engineering turns complex numeric systems into effortless daily human experiences. Understanding these foundational protocols empowers you to navigate technology safely. Subscribe to Node 01 to continue decoding complex modern technology. We unmask the unseen engineering breakthroughs shaping our connected digital world. Keep exploring the invisible protocols powering humanity's shared digital future daily. Node 01. Technology decoded.